In this recording, we're going to learn how to solve linear trig equations, sort of the basic trig equations. Let's start by solving a linear equation that has no trigonometry in it. Let's just write down on your paper the heading, and then write down this equation, 4x plus 3 equals 5, and solve for x. Play the recording when you have solved for x. Hopefully you did so, and you ended up subtracting 3 from both sides. Get a little 4x equals 2, divide by 4 on both sides, and x equals half. Or you might have written 0.5. Great. Now, when I present this equation, which looks pretty complicated, I'm looking for it to solve for theta in the interval 0 degrees to 360 degrees inclusive, and I want the equation to be 4 cosine theta plus 3 equals 5. Whoa, what, how? Back up. Remember, we just did something very similar. I want you to look left to right on the screen and see if you can pick up the similarity in the examples I chose. Okay, so hopefully you recognize that, hey, these are pretty similar examples. The only difference is that the cosine theta replaced the x. So what I'd like you to do is proceed in the same way as you did on the left side. First, get the cosine theta all by itself. So let's do those same steps. We'll take away 3. Got 4 cos theta equals 2. We'll divide. And we get that the cosine of theta is equal to 1/2. Okay, so up to this point, identical solution process, right? Now, but I'm looking to solve for theta, not cosine theta, so I have to go a step further. Hopefully remember, if I know the cosine is half and I want to find the angle, I use inverse cosine. Okay, so I'm going to go to my calculator, and I'm going to do the inverse cosine of half. And that works out to be 60 degrees. It gives me the reference angle. All right. Now, it turns out there are 2 places where cosine is positive. I don't know if you remember this, but all students take calculus. There were 2 quadrants where the cosine was positive. Why don't you think to yourself what those were and circle them on your diagram. And so hopefully you circled that the all quadrant, everything was positive, and the cosine quadrant, everything was positive. So in quadrants 1 and 4, I have a solution. So I will draw a reference triangle. Well, the one in quadrant 1 is pretty easy, right? Because the reference triangle of 60 degrees already has its angle. So I know 60 degrees is an answer. And then in quadrant 4, it's all the way around except for 60 degrees. And so if I do the whole circle minus 360, it would be a 300 degree, right? So it turns out those 2 angles that theta would be 60 degrees and 300 degrees. Those are the only angles within that interval 0 to 360. Notice also that the interval is given in degrees, so therefore I know I need to express my answer in degrees. Okay. I can sub those back into the original equation. I can also check by looking at a graph on my calculator. If this were a multiple choice question on the regions, I would suggest you just sub in your choices right away, or possibly look at the graph. Okay? Let's talk about how many solutions a trig equation can have, because you might be a little thrown off. Hey, over here there was just one answer, and I was pretty comfortable with that, but all of a sudden there's 2 over here. How am I going to know if I have them all? Well, think about it this way. Think about the graph of a sine wave. Okay? This is a sine of x graph, and I'm going to look between 0 and 360 degrees because that is a typical domain, a typical interval for the solution to appear in. Okay, so let's just consider between 0 and 360 degrees. How many solutions could there be? Well, let's consider it for negative half. How many times does that graph cross negative half within the interval 0 to 360? Well, there's one, and there's two. Two places. Try the next one. How many times is that graph equal to 1 within 0 to 360? Hopefully you identified, well, just one place. All right. How many times is it equal to 1/5 on that graph? Well, 1/5 is like 0.2 or so, so like maybe like right there on the way up, and then there on the way down. So I see two places. How many times is that graph equal to 0? Well, hopefully you identified that it's right here. 2, 3. It looks like 3 separate places. Now, yellow is not the best color to write in, but I'll write it in black. Okay. And finally, how many times is that graph equal to -2? Well, that would be like right down here. Never, right? It can never equal -2. So sometimes there are no solutions to a particular trig equation, even though they would be to a regular equation. All right, so with that in mind, let's consider another equation. We're going to look at two other examples, okay? Here are the steps that you're going to use. If you'd like to write them down, here are the steps we're going to use to solve a basic linear trig equation. If you'd like to write these down and play the recording. Okay, so hopefully you took time to write those steps down. We're not going to do any sage and scribe here because it's just you and me, partner. We're not going to do any sage and scribe. We're just going to solve for theta, okay? So same interval, 0 to 360 degrees. We know our answer needs to be in degrees. And we know it needs to be contained in that interval. Do pay attention. Sometimes in some questions, there's not a little underline here on the 360. In other words, it's just 0 up to 360, not including. So pay attention to that. Okay? All right, so let's work this one out. We first are going to solve this as if it's just like a variable here. I'm gonna give you a technique and see if you like it. If you don't like it, don't use it. But I'm gonna say let m equals sine of theta. In other words, I'm going to rewrite this with an m. 2m plus 5 equals 4m plus 6. Hey, hopefully you can see the connection. You see what I did there. Now just solve that for m. That's easy stuff. Go ahead and do that. Play the recording when you're ready. Okay, so you subtracted 2m from both sides, we got 2m. You subtracted 6 from both sides, we got -1. You divided, and we got m is -1/2. Therefore, sine of theta, what we replaced m with, is -1/2. Okay? So if that little technique of using the m helps you, stick with it. All right, now what I want to find out, and this is where I need you to dial in. If you're kind of spaced out, pay attention here. I'm going to ignore the negative on this, okay? I know because it's negative that needs to be in two quadrants. Let's think about what they are. A, S, T, C. Circle the quadrants where sine is negative, please. So hopefully you circled the third and the fourth quadrants. So our answers are going to be in those quadrants. But I'm going to ignore the negative when I put it into the calculator to do the inverse. So I'm going to do the inverse sine of just the absolute value of -1/2. In other words, half. And that works out to be 30 degrees. Okay? So what that is the reference angle. Okay? And I know it has to be in quadrants 3 and 4. So let's sketch out a reference angle of 30 degrees in quadrant 3 and a reference angle of 30 degrees in quadrant 4. Okay? You're going to get really good at identifying your special triangles here. So right here, a 30-degree reference angle in quadrant 3 means 180 plus 30. That works out to be 210 degrees. A 30-degree reference angle in quadrant 4 is almost the whole circle, but 30 less, right? So that would be a 300-degree angle. So that is the solution set for theta. Again, you could check by subbing back in. You could also check by graph. Finally, this last example is more complicated in two ways. First, the domain is expressed in terms of 2 pi, so that implies that the solution must be in radians. Okay, so consider that. And finally, there's a secant instead of a sine or cosine. So you're going to have to do a little more work when you work out the inverse. All right, so please write this down, play the recording when you're ready. Okay. If you want to use that same technique with the m, you may. Okay, so you don't have to do it this way if you don't like it, but I'm going to do it. I'm going to write let m equal the secant of theta. Okay, so 3m equals 2/3 m, or 2/3 times 3m minus 3. We're going to distribute here. So we've got 3m. 2/3 of 3 is 2, so 2m minus 2. Now work this out, so I'm going to subtract from both sides a 2, and so I've got 1m equals negative 2. Then I'm going to turn this back into secant. So secant of m, sorry, secant of theta, I'm getting carried away. Secant of theta equals negative 2. And you might say, well, I don't have any button for secant. True. So what you're going to do here is take the reciprocal of both sides. Let's make a little note about our math here. Take the reciprocal of both sides. In other words, if you know the secant is negative 2, what do you know about the cosine? Cosine is the reciprocal of secant. Negative 1/2 is the reciprocal of negative 2. All right, cool. Now at least I've got it in terms of a function that I can put into my calculator. So based on that, let's think about what quadrants theta could be in. ASTC, cosine is negative. Please circle the 2 quadrants that cosine is negative in. Okay, so hopefully you circled S and T because they couldn't be positive in all or C. Right, so we know it's in quadrants 2 and 3. Then I'm going to do what I did before. I'm going to ignore the sign on this and do the inverse cosine of the absolute value, just the positive half. Works out to be a 60-degree reference angle. Okay, so I know my 60-degree reference angle's got to be in quadrants 2 and 3. So the 60-degree reference angle in quadrant 2 will look something like this. So there's a 60-degree reference angle. That would be not quite 180. It would be 180 minus 60 would be 120. In quadrant 3, it would be 180 plus the 60. Okay, so there's the 60-degree reference angle. 180 plus the 60 looks like 240 degrees. Okay, so those are your two values, 120 degrees and 240. However, if you recall, we want the answer to be in terms of radians. So I'm going to do a quick conversion. 120 times pi over 180, and then 240 times pi over 180. Why don't you work those out and play the recording when you've got those both figured out in terms of radians. Okay, so hopefully you did the math there, and when you divide out this one, it looks like 2/3 pi, so 2 pi over 3 in here, divide both by 60, you end up with 4 pi over 3. So the two solutions to theta within that domain are 2 pi over 3 and 4 pi over 3. Thanks for watching.